Hello there. Today we're going to talk about 5-9, transforming linear functions. Now this one's kind of fun. What we're going to be doing is graphing lines and then looking at how changing their equation changes their graph. So what we'll be creating is something called a family of functions. And those are functions whose graphs have the basic characteristics in common. And a family of functions has what we call a parent function, which is the most basic function of that family. And typically, it's f of x equals x. That's kind of the most basic functions you can have. And then we will be looking at three types of transformations. And a transformation is a change in position or size of a figure. And we're going to be looking mainly at change in position today. So there's three types of transformations that change the position of a figure. The first one is a translation, and that is when every point is moved the same distance in the same direction. So it's kind of like a slide, you might have heard it called. A rotation is when you take the figure and you turn it around a point. And then a reflection is just like a mirror image of the figure across a line. So we're going to be looking at all three of those transformations and how changes in the equation of a line affect the graph of the line. So we're going to start out talking about translations, and I want you to look at the parent function here, which is this blue line, f of x equals x. Okay, and you see if it gets moved up to this red line, its equation changes to x plus 3. If it gets moved down to this green line, its equation changes to x minus 2. If it gets moved down to the purple line, its equation changes to x minus 4. Alright? These are called translations because I'm taking the line and I'm sliding it up or I'm sliding it down. Now what about the equation changes when I do that? Well, hopefully you can see that it's the y-intercept. Okay, I started with a y-intercept of 0. When I move it up, it became 3. Moved it down, it became negative 2. Moved it down even more, it became negative 4. So, here you need to write down this box when the y-intercept of a function is changed. Okay, remember the y-intercept is b. The graph moves up or down. If b gets larger, that means the graph is moving up. If b gets smaller, it means the graph is moving down. And this is what the problems will look like that you're going to work through on your homework. It says graph f of x equals 2x and g of x equals 2x minus 6. Then describe the transformation from the graph of f of x to the graph of g of x. So let's start with f of x equals 2x. Now, as we've learned, we can graph things out of slope-intercept form. If there's no b, that means it's 0. So I'm going to start at 0. And I'm going to go up 2 over 1. And I'm going to do that a couple times just so that I can make sure I have a nice straight line. Okay, and then I'm going to draw that line through there. So there's my line. Okay, and then let's graph g of x equals 2x minus 6. Now that one's going to start at negative 6, which is right here, and it has the same slope, so I'm going to go up 2 over 1, 2 over 1, up 2 over 1. Again, let me draw that line. Okay, so this line right here is g of x, and this line up here is f of x. Alright, so I have to describe the transformation. So what type of transformation is this? It's a translation because I've slid the line one way or the other. And how far have I translated it? Well, My y-intercept changed from 0 to negative 6, so that means it was a translation down 6. And that's what it would mean to describe the transformation. Okay? So that's what it looks like with a translation. Now, the next thing we're going to look at is rotation. Now, let's look once again, before we talk about what's in the box, let's start with our parent function, f of x equals x. Now, if it gets turned here to this red line, okay, rotated, its equation changes to 3x. If it gets rotated a little more, its equation changes to 5x. If it gets rotated this way, okay, down instead of up, its equation changes to 1/2 x. Alright, so what about these equation is changing? Well, it's the number in front of x, which we know is the slope. So when the slope changes on an equation, I know that that is a rotation. And it's a rotation around the point 0b, okay? Remember, b is the y-intercept. Okay, so here, these all go through 0, 0. So this is rotating around the point 0, 0. And it changes how steep the line is. You can see when the slope gets larger, the line gets steeper. When the slope gets smaller, the line gets less steep. Alright, like this purple one. So, once again, your problems are going to look pretty similar to what we saw before. Graph f of x equals x and g of x equals 5x. Then describe the transformation. Alright, so let's start with f of x. Okay, so this would just be 1x, and since there's no y-intercept, that means it's 0. So from 0, I'm going up 1 over 1. To get my line, once again, let me draw that line. Start it down here. There's f of x equals x. Okay, now for g of x, it's 5x plus 0. So it's going to start at the same spot. And remember, this is 5 over 1. So I'm going to start at 0, go up 5 over 1. Up 5 over 1. Okay, so there's my line for g of x. Now, you'll already know, since the slope changed, that this is a rotation. When it's a rotation, I always have to say what point it's rotating around. And remember, that is 0 and the y-intercept. So the y-intercept is 0, so it's a rotation about 0, 0. Okay? And then I have to say whether it gets steeper or less steep. Alright? Well, my slope got larger, so that means it got steeper. Or more steep. I'm not sure which the right one is. I think it's steeper. Alright? So the steepness of the line went up. Okay? So that's rotations. And then the last one we're going to talk about today is what we call a reflection. Okay? And now, a reflection occurs when your slope, okay, hopefully you'll be able to see this here. Here's my parent function, f of x equals 2x. Here's the reflection, g of x equals negative 2x. So what's the difference here? Well, my slope got multiplied by negative 1. See that? 2 to negative 2. So when my slope is multiplied by negative 1, that's a reflection across the y-axis. Okay? So, once again, let's look at an example. Graph f of x equals 2x plus 2, then reflect the graph across the x-axis. Okay, so let's get f of x graphed here. So I'm going to start at 2. It's 2 over 1, so I'm going to go up 2 over 1 from that point. Do it a couple times just to make sure I get a straight line. So there's f of x. Now, with the reflection across the x-axis, or the y-axis, sorry, my slope is multiplied by -1. So if my slope on f of x is 2, my slope on g of x is going to be -2. Now let's graph that. It starts at the same spot, except for now I'm going down 2 over 1. Down 2 over 1. So now I get a line that looks like this. It's a mirror image of my other line. Okay. Alright, and its equation would be g of x equals -2x plus 2. Now notice here I didn't have to describe anything, I just had to write the new function, and I did that kind of as I showed my work here. Here's my new function. Alright, so that's how I would do a reflection. So that's all we're going to talk about today. I do have additional examples of each of these, but I didn't think I could fit them all into the video. So if you need to see more examples, just ask me tomorrow and we'll go through an additional example of each type of transformation. And then the next video, 5-9 part 2, we'll talk about when there's multiple transformations to a graph, and then also kind of apply this idea to story problems. Alright? We will see you soon.